Today we're going to look at another strategy for solving rational equations. Our first strategy was essentially to take whatever function we had and get it down to a proportion. So if I had multiple terms on one side, we could get a common denominator, combine those terms using whatever operation was in my function, and then once I had one fraction equals one fraction, we could solve something like this by cross multiplying and solving for x. Today we're going to look at another strategy where instead of getting common denominators, we eliminate the denominators. So if we take a look at our first example, I actually do need to find the common denominator for this entire function to be able to eliminate my denominators. So if I take a look at what I have here, I'm going to factor any denominators that I can. In that case, that means this first term, I could factor the denominator into x times x minus 2 by pulling out my common factor of x here. And then I'm going to use my strategies from earlier in this unit to find my common denominator. And that means my common denominator for every denominator in this problem. So that would be an x and an x minus 2. And at this point, I've included every factor in every denominator for my function. So the common denominator for this entire function would be x times x minus 2. Now, I'm actually not going to rewrite this problem to have common denominators. What I'm going to do is multiply every term by this common denominator. We're going to multiply each term by this common denominator that we've just found. So here's what that will look like. I'm going to multiply this first term by x times x minus 2. I'm going to multiply this second term by x times x minus 2. And I'm going to multiply this last term by x times x minus 2. Now notice I'm not getting a common denominator because I'm not multiplying the top and bottom by this. I'm just multiplying by essentially this thing over 1. Now here's what that allows me to do. Remember, when I multiply fractions, we can reduce. So if I look at my first term, I can reduce x with x, and this factor of x minus 2 with this factor of x minus 2. And now my denominator here is just 1. So instead of 10 over x squared minus 2x, we have simply 10, or 10 over 1. In my second term, I have a common factor of x on the top and bottom, so I can reduce that down to 1. And I'm left with, plus for my function, 4 times x minus 2. In my last term, I have a common factor of x minus 2 on top and bottom as I'm multiplying. So now I have 5x over 1 left. At this point, I've reduced this down to an algebra 1 problem. I have no even x squareds in this problem. What I'm going to do from here is distribute, where I have some distribution to do. So I have 10 plus 4x minus 8 equals 5x. And then as I continue to solve, I'm going to move all my x terms to the same side. And when I combine like terms, like over here on the left, I would have 2 equals 5x minus 4x would just be x. So 2 equals x. We can check our solution the same way we checked before. I can plug this back into my function to see if it's real or extraneous. I could also check this on a graph. I'm going to go ahead and check this algebraically right now. So that would be 10 over 2 squared minus 2 times 2 plus 4 over 2 equals 5 over 2 minus 2. I've just plugged in 2 everywhere that I had an x in my original problem. And when I do that, I get 4 minus 4 over plus 4 over 2 equals, on bottom here, 5 over 2 minus 2 is 0. So I have a problem here, and if I were to keep simplifying, I have a problem here. These are both undefined. Since they're both undefined, that means that this is an extraneous solution. So I can cross it off my list. And for this problem, we actually have no real solutions. Similar to what we saw in our last section, just a different strategy to get to that same answer.